Today is going to be a very exciting day. We have amazing speakers who are going to speak to us about .NET, Azure, and most of the stuff. So if you are here, welcome. And if you have a question, you can always drop the question on the chat, or if you, there will be a session where we will take questions and all that. So welcome, and if you have a question, as I said, you can drop it. And this is our monthly meetup. We are recording this, so after that we are going to put it on our YouTube channel, and then you can go in there and maybe rewatch, or you can share this to other people for them to also watch and benefit from it. So we start with our first speaker, who is going to speak to us about domain-driven design when it comes to .NET. So let's start.
Okay, thank you, Clifford. Let me know, do you all see my screen? Because I started this sharing. Just react if it's okay. Okay.
Yeah, we can see.
So thank you, Clifford, for this invitation. I'm going to talk about domain-driven design, especially for .NET developers. I am Djoufson Che, a .NET full-stack developer with more than 3 years of experience, and you can connect with me following those links on the screen. So we go start, and we'll split our presentation into 4 different places. First, we will see what is domain-driven design. Second, we'll see the most pillars of the domain-driven design, meaning the key points or the rules to follow in order to apply this principle in our day-to-day applications. Then we'll make an hands-on practical example when we will refactor an existing code base following domain-driven design. We'll see how to modify the code, what are the benefits, and last we'll take question and answers. So let's start with the first part. What is domain-driven design? Domain-driven design is kind of a building pattern that aims to develop applications following domain rules, business rules of our customer. Meaning, if I'm developing an application for a restaurant, the variables, the way I will organize my code will be driven by the business design, the business rules. So I took this slide from a presentation of Jimmy Bogart, who is the creator of the library Mediator. I think most of the developers here use this library. He's presenting about domain-driven design. What are the benefits of that? And this slide says, my code, it sucks. Usually when we develop applications, we use a lot of utility classes, helper methods, and things like that, and many more. Why is that bad? It's bad because it spread the logic across a lot of components in our application. If you have a business rule, and usually what we do is that our classes are just focused like plain old class object that have just properties, but not any behavior. So when we use this kind of design, our application use the class to share data, but the most important thing, that is the compute, the behavior, is spread across multiple files, so it makes it hard to maintain. When we have a design pattern like that, a code like that, after a few years, we'll be afraid to come back and maintain it because we do not know exactly where this thing is implemented, We have to go through all the code, find where is this helper method, what is this doing. And the problem of that is not that the application will not work. The application will work, but we always have to remember where is the code hosted. I know if the code is in some helper class that we may not know at all, that a beginner that comes to the code base should have to learn a lot before contributing, you know. So that's why this code is bad. Then when we want to apply domain-driven design, there are some places where we should start. There's a book called the Blue Book, but this is too complicated. So I recommend you first to read a book by Microsoft called .NET Microservices Architecture for Containerized .NET Applications. This book is for absolute beginners. I mean, absolute web developers at least, and that has no knowledge about .NET or about domain-driven design, and that's a good point to start. After you get the basics from this book, you can go on and buy and read the blue book called Domain-Driven Design. That's from Evik Evan. This book is really complicated and will help you go deeper in this concept. So that are my recommendations. So next we'll see the pillars of domain-driven design. We already know what it is, but what are the rules to follow in order to apply this in our applications? I've registered 3 pillars. The first one is called ubiquitous language. Is the fact that in our code base in the real world we use same terminologies. Like if the client, the customer uses a word called shipment, in our code we should not call it cargo, we should call it shipment as well, because those are things the customer understand really well. And using the same language across all those different things helps us to remove an extra layer of translation, because when the client will uh, ask for an update or a new feature, we will directly understand what he's saying, what he meant to. So that helps us develop complex and robust applications, limiting the barrier between the client, the customer, and us. That helps us also maintain application in the long term, because those things will not change at all. Like the client, the customer will still call it shipment. An example is that if, for example, I'm building an application for, developers used to have weird variable names. We should avoid these things, and follow the rules that are driven by the domain, the expertise domain model. That's the first pillar. We should use the exact same language in our application, in our code base, as it is in the real world. Next, we see a concept called bounded context. This is about 2 things: reducing the coupling between components that has nothing to do together, and enhance cohesion between things that work together. Following this concept, we can separate our application in different aggregates, different bounded contexts. Each context is self-contained, can work alone, and do not depend on any other bounded context. Meaning, if, for an example, this is an online consultation platform that was built using this principle, we have 3 aggregates. The first being a doctor aggregate containing entities like the doctor, the category, and the rate, things like that. We have a finance aggregate and a business aggregate. Using this concept, we separate our code base into 3 aggregates, and all of these aggregates are self-contained. Why we do that? Because the doctor, for instance, do not change for the same reason that the plan or the subscription change. I mean, if in our code base we have to change how the plan class is implemented, we do not have to change how the doctor class is implemented, because those are 2 different concepts. Separating those like that lead to a more robust code and more modular code. Like when we will have to modify a class that is in a separate context, we do not touch anything else that was perfectly working. And then we can develop our application separately in a more modular way, in a more secure way also. How will our, if for the business aggregate, I have a consultation that needs to change a state in the doctor aggregate or the doctor entity or things like that, how will I do that without coupling my 2 aggregate, because they are separate? To solve this issue, we use a thing called domain events. So when we have to change or notify another aggregate that he must change the state or perform any action from another aggregate, we raise an event explaining what is the changes that are to be, what are the states that changed in our current aggregate. We notified it to the other aggregates so that we left them the responsibility to implement their change updates. In this way, the business aggregate, for instance, can grow separately, completely separately, ignoring whatever is happening in the other aggregates. And to keep this connection between those aggregates, we use the IGs, the identifiers. We do not use strong reference of the object or the class or things like that. We use an identifier because this is a thing that will not change over the time and is unique. Those are really important concepts to understand. Next, the last concept is encapsulation. As I said, we should left to the aggregate responsibility to change its state itself. So we should not enable outside world to modify the state of an aggregate or an entity or things like that. If we come back to the previous slide, we can see that there are entities colored in different color. Those are the ones that are connected to each other between different aggregates. Those entities are called aggregate root, and it's only through those aggregate root that we should interfere with an aggregate, not with these nested entities, only with the aggregate root. And we will interact with this using the identifier. And then the aggregate root has the responsibility to modify the state of itself or of its sub-entities, and that's made with encapsulation. And that leads to a robust code, a secure code. That's what I'm talking about, a secure code. Like we not at all enable outside world to modify the state of an entity or our aggregate. So that's about encapsulation. We'll see in practice how we can leverage all those principles to make a refactoring of an application. So I'll go straight to the code because that is a tech event. I'll share another screen, VS Code. I'll share my VS Code screen. Let me know if you can see it. Just make a reaction.
Yeah,
Okay.
I see.
So here is a simple application. I'll say it's an application that rewards members for a membership platform. Like if you have a member that has meet a certain criteria, uh, we reward him. So we have some entities in our model. We have the member class. It's just plain of data. We will change it. We have an offer type. If you can say, well, the member has first name, last name, email, and a list of offers and the number of active offers he has. And the offer has a member assigned to. So the member that is assigned to this offer, an offer type, the value of the offer, and an expiration date. So if you take a look at one of the implemented use case, we take this one, assign offer handler. This use case is to assign an offer to a specific member. If you go inside the request, we specify the member IG and the type of offer we want to assign it to. This is implemented using Mediator. I hope you're familiar with. The concept is just to handle
Please
requests and
can you zoom in a little bit for us? It's like
okay.
yeah.
Is it okay?
Yeah, it's okay. It's okay.
Okay. So we have this class that is our use case that we are implementing. If you go through the code, we can see that first off, we get our entities from the database. We retrieve them from the database using their identifiers. Then we compute something like that is to calculate the offer value using an external API. Don't go, we not touch it. Let's continue. We calculate the value. We calculate the expiring time, the date of expiring. and then we create the offer. And after we save it to the database. There are so many things going wrong here, but the code is working and is perfectly functional. How can we improve this code? We can improve this by first adding restriction on the creation of the offer. That's the first step. Like if you see this code, there are no rules about how to create this offer. If I don't specify any of those properties, I got no error, but my code will not work as expected. We first enforce the creation of this offer. There are several methods of doing this. You can create a constructor or create static factory class, up to you. For simplicity, I'll just generate a constructor for this entity. And the constructor helps us enforce how we will build our object, how we build our offer. So if you go to this, we can see that we now have a red line, meaning we have to implement it well. I'll do it right now. And close this with the, okay. Now, if I don't specify any of the required parameters, I cannot go any further. This is the first thing. Next, we can see that the creation of our offer is dependent on many other things, like the date time expiring, the value of the offer type, and so on. Meaning, if we have to create this, the client that use this constructor or want to create the offer must know that first off, you need to compute this. That is probably a business rule going on here. Like we switch on the expiration type, and based on that, we can say that we add a certain amount of days and so on. So this is a business rule that is spread on our, in this use case, we can leverage our domain-driven design to push it down on the creation so that we can share it across multiple places without rewriting our code. So we can go to this. Let me zoom it a little bit. Okay. So we can take all this code and push it down to the offer or the member, to the member and entity, because this is related to the member. We are assigning an offer to the member, so we can just have a simple API that says member.assign assign offer, specifying either the type, things like that. So that's what we will do. First, we also restrict the way that we create our members. Let's go to the models member. Okay, let's create also a constructor here. That is what we call encapsulation, because we do not enable the outside world to create entities the way they want, and we will enforce this to be only set inside the class by using this private keyword. So the setter is private. Outside, you can just get the value, but not modify it. That brings us to another error, because here we just increment it this way. This works, but it's easy to forget to do that, and that will bring us to a non-working code base. So we cut this, or this, cut all of this, and put it here. We say assign offer as my IGE suggests, but change it like that and make all the imports. Okay, we can see that we need an offer type, but we can easily inject it here. Offer type, that fixes the first bug. We need the member. We are inside the member class, so the member will be this, and we no longer need those two. And we need the offer, the value, so the value is an integer. We can inject it as well. So everything is okay. but we already have an offer variable, so we will just like that. Okay, this is how we will use our method now and going forward. We can just call it like that and provide all the missing parameters, offer type and value. That's okay. But now we see that going forward, we need the offer variable that was created inside this function. So we can just return it here and say that after all that stuff, we return the offer. Doing that, we are sure that we'll never have to write this or the assign offer feature again. It's already written and it's in a safe place. All that is related to a member is in the member class. You will not have to check either if it is an helper class or an helper method. We all have what we need here. So as we are returning the offer, we can catch it like that and everything is okay. You can see that we have no error. Then we have this complicated stuff that is used to calculate the offer value. In the way it's implemented right now, it's not testable at all. We cannot ensure that this piece of code is working without running the entire application. So we will create a service that will encapsulate how we compute this, how we calculate the order value, the offer value, and then inject it in our code. Then we create a public interface. We call it I offer value calculator that has just a single method, calculate offer value. Let's see if my EG got it right and implement it just here. Public class offer value calculator that implements I offer value calculator. And let's implement the interface. So we cut this code base and put it there. We cut this as well. We cut all this. We cut this and put it here in the implementation, and then fix the bugs. First, we need to add this keyword here, inject the HTTP client, inject it, and inject the cancellation token as well. Cancellation token, and then we just need the email and the offer type. Yeah, we just need the email here, the offer type here as well. That's okay. And then we return this. We return the value that we computed. So let's call our service. I should update the signature as well to enable token cancellation. And we are good to go. Let's inject this in our use case and inject it through the constructor. Remove what is no longer needed. The HTTP client, we are no longer need this. I can remove it safely. In here, just compute the value like that. Value equals the weight and email offer type name awesome. So in this way, we can easily test this class alone. And when it's time to test the whole use case, we can mock the interface easily. So this is how we can do that. You can also push it a little further down, like not compute this here, but inject the calculator here. That's up to you. But matter of fact, the idea is just that we split your code you make things look better. I'll move them to their own files like that and like that. Okay. Okay. If you go to our use case, the code is simpler. We just retrieve the entities from the database, we calculate the value, and we create the offer using this method. So we no longer spread our business logic across multiple classes. We just use the method that's provided by the class itself, because that is a business rule. The way we assign an order depends on the real world way of doing that, and it's a business rule. We just map it exactly to how it's done in the real world. So that's all about this introduction to domain-driven design. Hope you understood everything because you're way too smart. And thank you for all that. If you have questions, it's the time to ask them.
Yeah. Thank you for a wonderful presentation. This is amazing. So if you have a question, please, you can raise up your hand and then ask your question. We have one question from Charles. Charles, you can go ahead and ask your question.
Yeah, sure. So thanks for this presentation. It's a nice one. But I think I joined a little late. I think 10 minutes or so after the beginning of the session. But can you just summarize, just in maybe some few, just a sentence or so, what the domain driven can be described to be, if it's just a definition or something like that? I just want that to add to my understanding from what I observed from the code as well.
Okay.
Just
yeah, basically, domain-driven design is a practice that aims to build our application based on the domain rules, the business rules, and not based on our own knowledge. We first look at how it is done in the real life. We map in our application and follow the same exact rules. That's domain-driven design.
Sure. Thanks.
Okay. So if there is any other question? Yeah. Okay. So I can see there is no question, but if in case any questions comes up, please, you can drop that one in the chat for us. So thank you for your wonderful presentation.
Thank you.
At this point, we are moving on to our next speaker, who is going to talk about Akka and how we can implement that with .NET. So we have David Edem Mensah, who is .NET developer at Hapital, and then he's ready to share his knowledge. Yeah. So David, if you can hear me, let's start. Thank you.
Yeah. Thank you, Clifford. Can you hear me?
Yes, we can hear you. We can hear you.
All right. So can you let me know if you can see my screen?
Yeah, it's clear. Yeah.
All right. So I'm very glad to meet you all here, and also I really appreciate the fact that you've taken time off your busy schedules to make it up to this place. So my name is David Edem Mensah. I'll be presenting on getting started with Akka.NET in .NET 8. All right, so in this presentation, I'll take you through what Akka.NET is. We'll also look at the actor model, what Akka.NET relies on. We will also look at setting up Akka.NET with .NET 8. We'll also look at what it takes to create an actor and the concept of supervision strategies in Akka.NET. And then we'll look at the packages you can use to test your actors after creating them. And then we'll consider some keywords. So what is Akka.NET? So it's entirely a popular framework for building distributed, fault-tolerant, and scalable systems. It uses the Akka model, a pattern for structuring systems based on lightweight concurrent entities called actors to handle concurrency. So let's look at the Akka model. So the Akka model is a paradigm for building concurrent distributed systems. So actors basically are entities that do what? They communicate through asynchronous message passing. All right. And then each actor has its own state. So as you can see on the right hand side, you can see the actor here, and this is the mailbox of the actor. Don't worry about the terms for now. So what it does is that if you have asynchronous processes, or you want to perform some distributed activities, you can use the actor model for it. So you can have 2 or more actors in a system that will be performing the request for you asynchronously, and very, very effective. So you can see here the messages are coming inside the actor's mailbox, and when an actor receives a message, it performs an action, and the action spans across many processes. You can make database calls, write to your cache, update your cache. You can make HTTP calls and all that. So the actor model seems to solve or provide solve and make sure it provides you with a system that is concurrent. It also makes sure your system it has the everything it needs. Also, it ensures that your system is fault tolerant. There's no way your app is going to crash. It's going to control that, and we'll look at that when it comes to supervising your actors, and we look at scalability. It also helps you with that. So moving on, we'll talk about setting up Akka.NET in .NET 8. So .NET 8 is very powerful, and a lot has been done with respect to Akka. So there's this powerful package that you use, which is Akka hosting. Very, very simple. So this is what you need this time around in .NET 8. There you don't really have to be worrying about Akka autofact dependency injection and a lot of those packages that used to come with setting up your Akka. So you just need Akka.NET, Akka.hosting. All right. So with Akka.hosting, you can install it using the .NET CLI, or you can use the package manager console. All right. So let's move on to creating your actors. So how do we create these actors to make sure to help us create a scalable and a distributed system, right? So first of all, there's something called the actor system. So it's more or less like it's a very complex object, a heavy object where your actors live in. So we look at that during the demo, and you understand it further. So you need to create a system. Just one system is advisable because it's a heavy object, and it can create 1 to n number of threads. So you need an actor system. Okay, after you've gotten the actor system, actors can be created by extending either the receiver actor or the on-type actors. So by default, the package or Akka.NET comes with quite a number of actors, but the most popularly ones are the on-typed actor and receiver actor. But then this doesn't stop you from using other actors. Okay, so the difference is that the on-type actor takes any message. You can tell it any message at all, and then it will process it. But you have to be handling the message processing logic. If you have to do some checks, you do that. But for the receiver actor, it's unique in such a way that you can tell it specific messages. So okay, I can tell it, okay, so I want you to update my cache. So when the actor receives this message, then it performs the caching logic for you. All right. So moving on, we have properties. So before you create an actor, you need to give it or configure its properties. Okay, so props helps us. The actor's properties helps to give the actor some specific abilities. So this is where we can set the strategies, the supervision strategies for the actor. Supervision strategies, we look at it next. And also you can set a bunch of stuff to it. You can configure the hook-ons, which I'll touch on it, which is just human optimized configuration object notation. And in the hook-ons, you can set up so many configurations for your actor. So let's move on. So we'll talk about the supervision strategy. Okay, so we say Akka.NET provides us with a framework that we can use to build fault tolerant systems, right? So supervision strategies are essential for creating a fault tolerant, resilient systems in Akka.NET, ensuring that failures are handled predictably and effectively without compromising the entire the entire Akka system. So this is an important part with Akka, and we'll look at it in the demo. So this helps us to be able to set strategies in place in order for us to ensure that whenever our Akka encounters any issue in the process, we'll be able to revive it. And there are quite a number of supervision strategies, but some of the popular ones are one for all. So one for all, an actor can be created in another actor, and the actor that creates the second actor is the parent, and then the actor that is being created out of the parent actor is the child. So this one for one supervision strategy is a strategy that revives an act, just a single child actor when it fails, and then the all for one, just as its name implies, all for one strategy when all the children of a parent actor, and when one child of a parent actor fails, all the children are revived. Then we also have the backup strategy. So the backup strategy is also a very interesting strategy that enables the actor to restart itself in case if it encounters an issue. So moving on to, we have the directives. So a strategy will call or will end up in you applying a directive. So for instance, let's take the one for one. If your actor encounters a particular issue, in setting the strategy, you can end up resuming the actor, you can end up stopping the actor, you can end up restarting the actor, and you can end up escalating the issue. So escalating the issue is like trying to put your hands on your head and say, no, I think I'm the parent of this actor, but then I can't take it. So I'll escalate it to my parent or someone in the higher hierarchy. So that's the escalate directive. So let's move on to, we'll not really talk demo much on testing actors, but then you there's a guide to how to go about testing actors in .NET 8. So there's a package called Akka.TestKit. It's a very popular package. In it, it has so many features. It has the test actor, which is a very popular actor that helps you in testing your actors. So it serves as a default actor that sends the message to your actors during the testing. All right. So this testing Akka.TestKit supports the popular frameworks. We have XUnit 2 and XUnit itself. So we have the test kit also for NUnit and NUnit 3. And finally, we have the test kit for VS Test. So depending on the framework that you're using, you can also have the package for it. So now these are some key concepts. So over here, so sometimes when you are new, I might not touch everything, but then in Akka.NET, you might come across some of these key concepts, which might help you along the way. So we have tell. So how do actors communicate? Actors communicate by sending messages to each other. And technically, we use the method tell. Okay, ask. Ask is similar to tell, just that with ask, you the actor returns a message back to you, or you expect a response from the actor. So I'm asking you a question. So definitely I expect you to give me a response. And we have directive, just as we discussed, based on the supervision strategy, you might end up concluding on a directive. All right, we have the poison pill. So the name sounds funny. Yes, it's a poison pill. So when you have a parent actor and you have a child actor, you can forward, it's another term that will come. You can forward messages to the child actor to handle, and when it's done, in order to save resources and cause the actor to feel gracefully, you can give it a poison pill. So the poison pill is like a special message that you can give your actor after it's done. It will be terminated, but it will terminate gracefully, and gracefully in the sense that it will clear up all the resources that's used for you to save your memory, and also it will finish any on task and then terminate. So we have the context. So the context is the actor system itself, and then we have the sender. So if two actors are communicating, if one sends another the message, that one is the sender. Then we have props. Props is basically a configuration that gives the actor more properties. And we have the iActorRef. So iActorRef, when you create an actor, the reference of the actor is of the type iActorRef. And finally, we have hook-ons. So hook-ons are it's an acronym for human optimized configurable objects notation. So this is a set of configurations that we use to configure the actor. So you can, if you really want to control how your actor logs, you can set the configuration in the hook on, and probably you can use debug actors use info by default. You can set the configurations for how your actor will log its messages. You can set configurations for how you set some database configs to be handled in your actor. So at this point, I would like to pause on the demo and then pause on the presentation, and let's see some demo. All right. So can you all see my screen?
Yes.
Yeah.
Okay, so this is the part that gets interesting. This is the interesting part. All right, so I have a project here, demo project here, and this is the default ASP.NET Core Web API that app that you get when you install it. So let me just run it. It's the default one that the weather API. So this just gives us okay, a list of weather info or weather forecast, the country, the temperature in Fahrenheit, and in degrees Celsius, and then the date. So this is basically it. So we are going to create an actor that will just do a simple thing. We'll tell him the weather forecast data, and then the actor will look for the country that has the highest temperature, and it will just log it. So very simple. But hey, you can do so many things with your actor. So let's go ahead. The very first thing is we need the Akka.hosting package. So we can do that by installing using the Nuggets Manager, or you can use .NET CLI or even the package manager console. So let's do for it. So this is it, Akka hosting. So I'll install it. All right, so I'll set. Okay, we are good. It has been installed. All right, so we can move from here. We can close this, and now let's go. So the very first thing is actors. We communicate to actors using messages, right? So let's go ahead and create our message. So I'll first create a folder here, and I'll name it. So I'll name it. So just components. I'll just make it simple. Just making actors, right? Then inside this, I'll just create a folder just to keep my messages. So let's say the messages we tell the actor, right? So the messages can be anything. It can be string, integer, objects, or anything, depending on the context you want to use. So let's create a message called weather forecast message. So let's name it weather forecast message. All right. So by default, you can use anything for your message, but mostly it's advisable not to actors. The state of actors are not are immutable, so you can't mutate them. So I'm going to use a struct for that, and I'm going to have my tell my actor an array of weather forecast. So okay, so what data do I want to tell it? What message? What's the type? So it's going to be a weather forecast data. So this is it. So this is how it looks like. So this it, and I'm going to tell it an array of this weather forecast. As you can see, I have it here this way. All right, so this is it, and then I'll just name it weather forecast. Then I can just set the get here. I can then go ahead. I'll then go ahead and create a constructor. Then go ahead and create a constructor and then initialize it. So here I can just double click and press Alt Enter. Okay, cool. And then add the parameters this way. I can then escalate this to a primary constructor if I want. So very simple. It's a new feature in .NET 8. And then we have it here. Okay, so our actor message is done. So now let's go ahead and create our actor. This is where it gets interesting. So let's create our actor. So our actor is going to process our weather forecast data. So we can call it a weather forecast processor actor. You can name it the way you want. Okay, so very first thing we are going to inherit from the receive So from the receive actor, right, which I said is a special actor that provides you the chance to send specific message to it. So all right, so this is it, right? Our actor is going to have a private field for login, so we inject the iLogger of this actor here. All right, so we have our logger field here. Now let's go ahead and create a constructor. So CTR, okay, so we can inject this, we can add it here. All right, we are good. So now what makes this a special actor? So we can tell it to receive a message. So the message that we want it to receive, we use the receive method here. So receive async, and then what's the type of the message? So we want it to receive a weather forecast message. Very, very simple. All right. Okay, so when you receive the message, what do you do? So this is what you do. So you pass a handler here, okay, which takes the message, and then all the action goes in here. You can do a lot of things in here. You can you can send messages to other actors. You can write to databases. You can read from a database. You can do a whole lot of functions in here, right? So our own is just very simple. We will take the message, look for the country with the highest temperature in degrees Celsius, and then log it onto the console. That's basically it. Very simple. So let's go ahead. So first of all, we are just going to do a try catch, but this is going to get lengthy. So I can just come down the way here and instead create a private method here that is going to be, you can create, and then it's going to return tax, and I'll just call it process. So weather forecast, right? Or just the weather forecast. It's okay. So this is the same handler here. We just give it the message. So this is the message we want to tell our actor. So we tell it, take a weather forecast. Yeah, so it's going to take our weather forecast data here, an array of it. So the message here, and then we pass the message here. All right, so in here we can just bring our try catch like this. All right, so we can put the exception here, and that is it. So instead of this approach, you can then make it simple and pass the method handler here. Okay, then you go ahead. So now here we can just start with our logic. So let's first get the weather forecast. So let's say weather forecast. So weather forecast just one. So here, remember in our message, there is a weather forecast property, which is an array of weather forecast. So we'll look through and get the one with the highest temperature, and then we'll just log it. So that's what I come to do. So the message dot weather forecast dot order by. So we can order by the temperature in degrees Celsius to temp C. Then we can just get the first of our weather forecast data. So when we get it, we are good now. So assuming everything is equal, you can just go ahead and log the back. So this is just a basic implementation of what an actor can do. So we have our logger here, so we can see the highest weather, the highest temperature, right? Of, so we can put a placeholder here for the temperature. So temperature of degree Celsius was recorded in, then we put a placeholder for the country. Just want to just log this. All right. Okay, so since we've set some placeholders, let's put in the variables. So weather forecast data dot temp C of the one with the highest temperature, and then the country. So weather forecast dot country. It's very simple. So here we can just simulate this. Just await task.complete the task here. And should in case we encounter an error, we just go ahead and log the error. But you can do any other thing here. So first put the error here and just say an error occurred while processing the weather forecast data. Right? Very simple. Okay. So now that we have our actor and what it's going to do, so this actor here is going to handle the processing of our weather forecast data. So this is going to reduce the logic in our service. That's the service handling our business logic. So sometimes actors are very good for fire and forget activities. So we don't really need it to return anything. So we give it to you, hey, take my burden off me and handle it. And that's basically it. So we are done here. So now that we are done creating our actor, remember when you're creating an actor, you need a system. Then you need to prepare the properties of the actor, and then you create the actor. All right, let's go ahead then. So if you are building an actor in a normal console app, you wouldn't need much with respect to registering your service collection. But then if you are going to register your service collection, you want to register your actor in your service collection and use it as a dependency elsewhere. Then let's go ahead to the next step. So now what we are going to do is to show you how to register your actor. Okay, you build a nice actor. How do you use it then? All right. So the only way to use it, if you are using it in the web API, so let's create a class called service collection extension. Right. So first of all, it's an extension method. So let's make it static extension class. Sorry. Okay. Then let's create our method here. All right. So it's going to be static iService collection. And then we'll call it. You can call it register our actor. So that's very cool. You can give it a name that matches. So since it's a static class and it's of the extension iService collection, as usual, just need to make it this iService collection, and then we call it services here. So we are done. Right. So now let's go inside. So first of all, we check if the services is now. We just throw an argument now. So we have an argument now exception dot throw if now. So this is very simple. You can use this instead of checking if services now. In just one line of code, we achieve a lot. All right. So now this is very interesting. So let's talk about creating our system. So first of all, we need to give our actor system a name. So actor system, right? So like this. Then we give it a name. So just to keep it simple, I'll just call it my weather forecast actor system. Okay, just a simple name. Now, previously we used to go by this approach, which is very weird, but then there is this important method that comes with the extension method that comes with the service collection. It's used to handle the registering of your actor service. So we go ahead and say services dot add Akka, all right, and everything goes here. So now what does it take? We can see it takes an actor system name, which we already have, and then an Akka configuration builder. So let's go ahead and provide our actor system here. Now it takes a delegate of Akka of the type Akka configuration builder. So we can put our builder right here. So since it's a delegate, if you're a JavaScript user, just know your Lambda thing. This. All right. So we can just make it simple and call it our builder. All right. Now the builder has methods that you can use to prepare the preparation of your actor before you register it or build it or use it for any other thing. So we have a method like builder dot add hook on. Remember the keyword hook on here. So if you want to set configurations for your actor and to handle login and any other configuration that you can set on your actors, you can use a hook on. So if you have a hook on, you can add a hook on directly. If you have a hook on file, you can use it. But we'll keep things simple here. So what you're interested is with actors, right? So that is where we continue. So with actors, so this with actors method here is what we need. So first of all, what does it take? It takes your a system. It's a delegate that takes the actor system and then I registry. But if you look at over here, we have extra overloads. So we have 2 more overloads, right? And then I want us to quickly go inside. There is one that we'll use. So with a sorry, here it takes 3 more overloads. So there is one that we'll use. It has the system, the I registry, and then the resolver, which is very important if you want to configure your actor to resolve its dependencies before it's being created. So let's go ahead. So once again, it's a delegate, so we can pass in this methods here. So we have the first one is system. You can call it a system, and then the second one is a registry. All right, and then the third one is the resolver. So resolver is complaining. Okay, don't worry, I'll sort you out. Okay, yeah, good. So we have the system here, which is your actor system. It's going to help us create our actor. We have the registry here if you want to register your actor in the service collection so that you can inject it later on in other services. And we have the resolver here. So this resolver here helps to resolve the dependencies that your actor rely on. So let's go ahead. Very important. So now that we are coming to create the actor, so the very first thing is we can create a strategy. So this is where the strategy comes in. So we're going to give it strategy, right? We're going to give it a 1 for 1 strategy. All right. So with this 1 for 1 strategy, what are we trying to say? So what does it take here? So here, maximum number of retries. Okay, so in case there is failure, we can set the maximum number of retries to 4, 5, 6, any. Let's retry my actor 3 times. And then what's the interval? So time span. Takes a time span here. So okay, after every 3 seconds, time span dot from seconds. All right. So let's say 3. You can use 2. By default, it's 3. If you don't specify. So let's use 3. That means what it means is that it should, in case my actor fails or something happens, we define next. I want you to revive my actor 3 times. But first of all, for every interval, wait for 3 seconds and then revive it. Wait for 3 seconds and revive it for 3 times. So now this also takes it has 6 overloads, and then the last one is exception. We have an exception here. We can pass. So this is where we handle the reviving or handle any issue that our actor encounters. All right. So very simple. So here, strategy will cause you to end up in a directive, right? So we can, one of the popular exceptions that we can handle is the actor initialization exception. So first of all, we'll say if the exception is not actor initialization exception, right? So we can return a directive dot stop dot resume, right here. So here we can handle any other exception, but then we want to just focus on this particular one, right? If the actor is an actor initialization error, which is very, very critical because we need our actor to work, and if the actor can't be initialized, then we have to stop. So here, if it's anything else, we try and resume the actor by using the strategy 3 times after every 3 seconds interval, right? But if it's not, and it's this initialization error, which is very bad, we can just tell the system to terminate, and then we'll say wait for 1 second or 1 millisecond, 1,000 milliseconds, and then finally we can end with a directive that okay, if it's an actor initialization exception, come on, you need to stop. But if it's anything else, let's just revive it. And this is how we handle fault tolerant systems using actors. So we have our strategy here, right? So now with our strategy, we can then go ahead and create our properties, right? So let's go ahead and create our properties. So we say our prop for our actor here, which gives the actor more properties like the vision strategy property and others. So now we'll use the resolver here because our actor has some dependencies. Okay, then we'll say, okay, so what actor do you want to create the properties for? So we can go ahead back to our weather forecast processor actor here. We pick it and we put it here. All right, then we call it, but we are not done. We have to add a supervision strategy. We can go with it without giving it a supervision strategy, but I know it's going to be very, very bad to have a system like that. So let's add with our supervision strategy here so that our actor can handle any force that comes along the way. All right, so we need an actor system. We need the properties of an actor. Now this part is very interesting. So now that we are done, we need to then create an instance or get a reference of our actor and then register it in our service collection, and then we'll be done. So let's say our actor. So how do we create actors? We create them in the system. So we use the system.actor of. Okay, so we create actors using their properties. Yes, of course. So we use our prop here, and then you can choose to end here, but it's advisable to give your actor a name. So what name do you want to call our actor? So we can just say name of here. Giving your actor a name helps when debugging for an issue, when debugging an issue. So if you don't give it a name, Akka will give it a random name for you, and it's going to be very difficult to recognize your actor during debugging. Okay, so now that we have our actor here, remember the actor reference keyword here. So this is it, very simple. So it gives us a reference to our actor. So we have our actor now. Instead of using singleton and all those registering methods, we can just go ahead and use this register here. Very simple. So register. So registry dot register. So register our weather forecast processor actor here. This type, and then let's pass the reference to it. So this is it. We are done. So you can register you can prepare so many properties for different actors. Your system might have 2 or more actors. You can prepare their properties, get reference to them, and register them as follows. So you can create another actor here and register it here. When you're done setting the properties and everything, you can register as many as you want in here. That's very simple and very nice. It avoids a lot of auto fact dependency issues, and all those things we used to do in the previous version. So now we can return our services. All right. So this is very simple. We have our service collection extension method here. So we can go to our programs file here and just come and call it here. So builder.services.register. We call it register. All right, so I can see it's finding an issue looking for our namespace. So let's just bring here a namespace. So let's say using this namespace here. All right, so we are good. So we are sure to have it, the method here, the register actor, and that is it. So we are done. If you are not going to use service collection, you don't need to register your actor in any service collection. Then right after creating your actor here, you can just start telling it. If you're using it in the console app, you can just start telling it, hey, send Ghana into paradise, something of that sort. But anyways, we'll tell it a good message later. Okay, so we've registered our actor here in our service collection. So now, how do we use our actor? Okay, so here to keep things simple, we will go back to our controller here. And okay, so when somebody calls this endpoint, we want to perform a fire and forget logic here. So what we want to do is that we just give our actor the list of weather forecasts, and then it will do the processing. Once again, when you get into your actor, you can do anything in there. So what we just do is to just take the array of weather forecast and look for the country that has the highest temperature in degrees Celsius, and then just log it. Very, very simple. So here we are using the controller here, so we need to inject. So in order to use your actor, since we've registered it, you inject it by using the I required actor, and it tells, okay, what is the type of your actor? So ours is the weather forecast and processor actor. Then we just name it. I just name it rec actor here. So with this, how do we get it? We create a primary field and then get the actor, the reference of the actor, or we can just come and call it directly here. So you can just say rec actor dot. So we need to go a step further to get a reference of the actor. Then now we have the actor, and then we can tell it a message. So this is how interesting it gets. So we tell him an array of, so we say a new, what's our message? This is our message. It's a struct. So a new weather forecast, okay, with weather forecast equal to, then we set it to our results here, and we are done telling the actor. Okay, so it's complaining. Let's bring Akka. Okay, we are good. Okay, so very simple. So this is how to tell actor messages. They take the message upon hearing the message or receiving the message, and then they perform an action. So very simple. So we expect our actor to take the weather forecast and do what it's supposed to do. So let's go inside our actor here. We have the receive async method here. So when the actor receives this message, it will perform this function. So let's go inside, which is right here. Okay, so we expect our actor to do this. So another example is, you can, if you are creating, if you're adding new users, and for instance, in your business logic demands you to add new users and create default wallets for them, or add new users and set any other thing that doesn't expect you to return, you can just give it to the actor, tell the actor, and it builds it for you. It handles the logic. So let's put our breakpoint here. Let's run our code to see if everything is working. Okay, so the web server is listening on ports. All right, so let's check to see if everything is good. So let's run it. All right, so you realize that I put a breakpoint here, so it has. Okay, so let me just let it slide, and then let me put a breakpoint right in the controller. Then I'll just. All right, so let's run it again. Okay. So let me just, yes, this is fine. Now let's run it again. Okay, so very simple. We call the endpoint, we get it, then it hits the controller. So these are the countries here, just for storing an array of countries. So we are in here now. So we get our weather forecast data, and then here, okay, step out. Yes. So next, we just tell our actor, handle the weather forecast data. So it just takes the burden from you and does the logic elsewhere, whilst you can continue with the rest of your business logic. So right here, I'm just going to continue so that to go inside the actor. Okay, so all right, so let me go into my actor. Okay, let me just run it one more time. So let's just quickly move this to just the actor, and let's just focus on the actor. So let me put the breakpoint back here. Okay, and also just one here. Right. Okay, so our server is ready. Okay, so it's ready. So let's use the endpoint. We try to get, it is this first breakpoint. Then when it gets here, to tell our actor. So let me just quickly hit the breakpoint. All right, so we are now in our actor. So our actor will be handling this separate, whilst you handle the rest of the logic. So here, the actor, and if you look over here, as you can see, so we take the data, we look for the highest one, and then we log. Then we continue. So sometimes you even realize that before even the actor will be handling it, your response, your API response will just be ready. So the actor will just be handling it for you concurrently elsewhere. So let me just continue for simplicity's sake. We have our response here, and then when we check the logs, So come on, let's just run it again. All right, so just check. Okay, we are good here. All right, so let's go back and run it again. So we just want the logic to start from here. Okay, so our web server is listening on port 7053. All right, so let's go ahead. Okay, so let's see. So which country has the highest temperature? That's who? Togo. Wow, 47 degrees Celsius. Okay, so let's see. So we log, then we await the tax, and we continue. All right, so let's check our logs. All right, so it's still okay. The logs are not showing. Let me just quickly do one more check. Oh, I think I was in a hurry. Okay, let's just run this in. Okay, so let's run it for the last time and wait for the logs. Okay, so our server is up and running. Okay, so it's ready now. So we can have it here. I don't know if I'm moving too fast, but just pardon me. So, okay, inside our actor, let's see who's the one with the highest. So the highest data is Qatar with 25 degrees Celsius. Let's continue. Quick point here. Okay, so we can hit file logs here. Okay, so our log is not showing, but let me just see. Possibly it could be the settings. Let's see if everything's okay in our actor. Okay, we're good here. We're good here. So iLogger. Okay, we're good here. So let's just check our settings and just make this the bag, just everything. Okay, so we okay here. And then okay. So if it doesn't come from here, we'll just check how we're handling the resolving, right? Okay, so who's all right. Okay, so let's just have a check at our resolver. So let's see if you're all good there. So resolver dot props this. Okay, this will help us to resolve our dependencies that our actor depends on. So we are good here. We are also good here. Also good here. All right. So it's good here. All right. So we are good here now. So let's go. Okay, cool. I'm sorry I'm taking too much of your time, but I just want to get this thing done, then we'll rebuild. So basically, that is what we intend to achieve. And I hope you've at least have an overview of what actors can do, how you tell the actors messages for the actor to perform on or act on, and also to how you can see how to create concurrent and fault tolerant systems using Akka.NET. So it's very, very powerful. There are a lot you can do with it. You can create actors to communicate to different actors on different networks. So I can have a network here and another with an actor here, and I can have another network elsewhere, and I can make the actors send messages to and fro very fast. And there are a whole lot you can do with actors. So I've rebuilt. Let's see, we go here. All right. Okay, so our server is up. Okay, the breakpoint has been hit. Let's go on. Okay, so we get our weather forecast data. Step out, step out. Okay, so at this point we tell our actor to process it, right? And we return the results, right? Okay, let's quickly jump into, let's go into the actor real quick. Okay, so we are inside the actor now. As usual, we get the temperature with the highest, the weather forecast data with the highest temperature, and then we log. Okay, so after logging, come all the way here. Okay, so we are done. We are done. We are done. At this point, it's okay. So let's check our logs. Okay. Right. Well, I don't really know why it's behaving like this, but not to take much of your time. Sorry for the end wasn't really good, but then I believe you have an idea of what you can do with your actors. I'll look into this and I'll push the share the link to the final code on my GitHub so that you can check it up and then see what you can do with it. So thanks so much. I'd like to bring my presentation to an end.
Okay. So thank you for a wonderful presentation. So I can see there is some kind of questions.
Wow.
We have Timothy's here. So sir, if you can hear me, you can go ahead with your question. Yeah?
Good afternoon, David. Can you hear me?
Yeah, I can hear you.
Yeah. Especially when it comes to the fire and forget. I mean, there are other alternatives, like, for instance, let's say using, let's just say, mass transit and then something like Azure Service Bus to help with your fire and forget. Now, I want to know, how does the actor model have an advantage over using an approach such as message queue, like RabbitMQ, Azure Service Bus,
or Kafka,
or Kafka?
Yeah, Kafka. Yeah.
Exactly.
Yeah. Okay. So your question is broader and it's beyond this. But then, well, with respect to the actor, it handles concurrency with in a lightweight manner. You have your actors, right, which are very lightweight, created for you, and unlike that of let's say Kafka, for instance, with this you have the concurrency being handled within your code, right? And the actor models are lightweight. They are within your code, and you can create numerous of them. And I think the size of one actor probably in your code is around 300 kilobytes, right? And this performs concurrency. It handles concurrency very easily as compared to the message queuing. And this is within your code, right? Within your code, and this actors that you create in your code come with various supervision strategies to help you build resilient and stable systems. So with respect to the message queuing, you can probably use the actor to produce any data, further data, any data to your cluster, and then consume it from there. So actors are very good and they are very fast and reliable when it comes to handling something like that. So basically, you can have a scenario whereby after a customer, you handle an order. So after the order is being processed, you can you can tell an actor a message, and then the actor can take it up and then produce the message to a particular topic, and then you consume it from that point. So I guess at least this gives answers your question in a way.
Yes, it does.
Okay. So I can see we have Foster too. You can go ahead, Foster, and ask your question.
Okay, David, I'm grateful for your presentation. It's been quite wonderful. Thank you so much. But there is one question. I'll be more grateful if you can throw light on it. And per my understanding, the endpoint or the weather endpoint was return the country with the highest temperature. In a layman's view, maybe, or a beginner programmer, just an assumption. I can just use maybe some techniques to just grab the country with the highest temperature without the need for this Akka.NET implementation. So in the concept that you just implemented, what problem in particular does it solve? Since we can just get a country with the highest temperature, what is the need of this Akka at this point?
Yeah. So, okay, this was just a basic demonstration, right? And it might not really play the role that Akka does for you. But then, of course, you can easily get the country with the highest temperature and then just return it, okay? But if you take a look at our API returns 5 temperature data, right, from different countries, okay, which is what we are to return. But then, let's say we want to perform an extra logic, which is take the data and then probably record the data somewhere or send a notification to our users telling them the country with the highest temperature. So with this, an actor comes in here, you can tell the actor to just carry on with this activity while she focus on just returning the list of weather forecast data to as the response.
All right, thank you, David.
Okay. Okay, so I think okay. Yeah, okay, Philip, your hand is up. Do you have a question?
Yeah, Philip.
Yeah, hi everyone. Thank you. Okay. I don't know whether that's what you meant, but per what you just answered to Forster, I I heard you saying that you can let the actors perform other taxes for you whilst you go ahead with your own business logic. Is that right?
Yeah.
So if yes, so is it like is it working like some kind of a background service where it's just playing its role for you, and then this your main controller is handling it on logic, I mean business logic?
Yeah, so it's tantamount to a background service. By background service, a whole service on its own, right? So this is more or less like focusing on your business logic while you perform other operations. So let's say I want to go to let's say let me use the order for instance. We are an e-commerce company, and then let's say we an order comes through and the order is successful. With the business logic, we have to ensure that the order is successful. Then if the order is successful, the next step we do is look for the customer and then send a notification to the customer, and then after sending a notification to the customer, we'll probably update the order in our transactions table somewhere. And then when we are done, we'll just return the response to the customer that, okay, your order is successful. You realize that it comes with a lot of steps, right? And these steps can be handled concurrently elsewhere by an actor, whilst you just focus on returning the order, the status of the order. So actors come in to handle this thing. So you can use them as fire and forget. You realize that the saving of your transaction, the sending of the notification to the customer, it's not part of the core. It's part of the core business logic, but then they can be handled elsewhere. The endpoint is just to return the status of the order. So you just go ahead, return the order, and let the actor do the updating or inserting the record into the DB, sending the notifications and all that. So any logic, the notification logic and then the saving logic can be handled in the actor, whilst you just return the response to the customer.
Okay. So if what happens if, let's say, we want to save an order for a customer? Okay, I place an order that I want burger. Now we are saying that the controller should just return the response to the customer, right? So if the
that's
actor,
your business logic.
Okay, if the actor is unable to even save that order to the database, then how are we going to handle that, since we've already returned the response?
If you rely, so you can ask the actor instead of telling it. So the actor, so the actor can return a response for you. Maybe this is synchronous. So the actor can return a boolean for you, right? Then you further use it. You can do the saving logic here. So let's say you do the saving logic here. So you save, and then you are waiting. Finally, maybe it was false, couldn't save, right? Some field dependency, right? So you just return false. And this time around, instead of using tell, which doesn't give you any response, you use ask, and you just get the response here. Let's see, response. So response somewhere here. Then you can take the response and then do whatever you do with it. But mostly, it's very, very efficient to just handle fire and forget activities with the actor. So you just fire it. It does a notification for you whilst you mind your business elsewhere.
Okay. Thank you.
All right.
So I can see there is a lot of questions. So let's first pick Charles. Then we go Foster and Timothy again. So Charles, if you can hear me, you can go ahead. Then after that, we pick the rest.
I can. I'm just still trying to grasp based on the questions that has been asked so far. I'm still trying to grasp the core purpose of this Akka implementation, right? So I am picturing it like this. So if you can correct me with what you are saying, that handles is somewhere means looking at threads. Your controller thread is on a different thread, and then this actor stuff or this Akka stuff also runs on a different thread. So it's like a parallel processor stuff like that, which runs on different threads that you can have some parallel processing capacity in there. If that is correct, you can correct me on that. And then also in that context that you just said that there is a notification that must be sent, there is maybe some event logging that must be done. If you're considering a microservice architecture where there can be separate microservices that are handling these separately, like somebody said Azure Service Bus, where you might be pushing some logs into a bus, or let me say a queue where a different microservice is picking the queue, their records, and then pushing into a DB and stuff like that. These are separate microservices, right? But in this case, there's one system, but then you haven't that kind of separation in that one system. I'm still trying to grasp the core understanding of this implementation. So if I'm correct, please correct me. With this, you are building one system, but you're achieving these kind of separations in that one system or in that one solution.
Yes.
Is that, am I correct?
You are not, yes, you are correct, but then I will just add something small. So your microservices will be located at wherever they are. but you can perform the logic that interacts or work with your microservice inside the Akka. So
that is by pushing messages.
Yes, so you can push the message if you want to use it that way. You can also produce if you are using a message queuing system to service somewhere. You can produce the message and do the producing logic. You can do the producing logic inside the Akka.
Okay. And if I get you with the management, I don't know if it is management or where you said if it fails or you want to restart it several times or something like that. You mean to say that should I be publishing a message and it fails, there should be some retrial mechanism or the rule you should follow to handle the failure and stuff. That is what you meant by that, right?
Yes, exactly. So
okay,
like I said
so
earlier
basically,
on,
okay, so basically it means there's some kind of like a pops up stuff. If I know, I don't know if anybody knows of DAPA or so, but there's like a pops up, something like that.
Yes. So you something of that sort. Yeah. And also too, if you are from a JS background, it's more or less like how you handle events on this, do this function, on this, do this function. So you can equate it to that. But not pops up entirely. Okay, so Charles, I think you are done, right?
Yeah, so we have
I'm good. I think I've got some clarity. I would find out more. I hope there are documentations.
Yeah, so I'll share links so that you can access it in the chat.
We have Frederick. I think Frederick was asking a question. We have Frederick Utrot here. Yeah. So if you can hear, you can go ahead.
Yeah. Good job, David.
Boss, I just salute.
Oh, you know me already?
Of course.
Okay. All right. Nice one. Nice work there. I just was so much interested in your presentation today that I had to wake up at dawn. It's still dawn here to just watch you present. So
wow.
Yeah, I'm really glad you did a good. Yeah, you did a good job, and I've also learned a lot. In as much as I've been using Akka for over, I don't know, a number of years now. So you did a great job. But for some of your audience, some of the questions they're asking, let me just try and just make, give a very brief overview of the whole purpose of Akka. And an analogy, right? So consider a simple system like David mentioned. You have an order coming in. If the order is successful, you want to send notification. And there could be 10 different channels you want to broadcast your notification to. So the person needs to get an alert via SMS, via email, maybe via FCM, right? So within your system, when you are done, so the whole idea is that you get a request. You don't want to, you want to try as much as possible to avoid doing things like an ask, because you want to build systems that are like very independent on each other, right? So a request comes, you say, hey, I acknowledge that you want to process this order. I'll let you know once I am done. So you have all these other let's call it workers or maybe food soldiers. Let's call them like some food soldiers, right? This person is in charge of sending email. This person is in charge of sending SMS. They are two independent processes. One doesn't depend on the other. So you don't want to. So literally, your normal code you write, send SMS. Your next line you come and write, send email. Then if this is successful, they don't depend on each other. They are mutually exclusive, right? So you just can use an actor system. You can build like multiple actors. You broadcast the message. So there's a concept called broadcasting. You broadcast the message, and all the actors that rely or needs to subscribe to that message, like some pops up thing you are saying, you can also use that to do it. So that sending an email and sending an SMS doesn't have to. Nobody needs to wait for each other. You say, "Hey, I am done with the order." SMS kicks in, it sends a message. Email kicks in, it sends a message, and you get the benefit of either doing that concurrently or in a parallel form, right? So that is some of the advantages you get with, using actors. And there are times that you also want to just do something and go away with it. Like you don't want to allocate some memory and it will just be in your hip and doing nothing. So you use actors. You can spin an actor on the fly, do the work, and you kill it. Then you and release your memory because that guy wanted to do something very brief, so it's very ephemeral, short-lived, then it's gone. So you can spin an actor for that particular thing for it to be done, and once it's done, you can kill the actor and you free yourself from any resources that was allocated to do the job. So that's just something brief I wanted to contribute to what David said. So yeah, thank you and good job. Keep killing it.
Yeah. Thank you very much.
Yeah. Thank you so much. Thank you so much, sir. We have Sir Timothy here who wants to ask a question. So Sir Timothy, you can go ahead, and then I can see Foster is also back again. So yeah.
Okay, I think Frederick gave more clarification on the ask because I was about to ask, wouldn't the ask block the thread when you are processing your business logic? But I think he threw more clarity or clarification that we should try as much as possible to avoid the ask. But then secondly, I wanted to ask where I'm coming from. This similar fire and forget. We use a lot of mass transit, a lot when it comes to these for operations like this. So usually because of memory, as it was spoken, we usually use the cloud to spin up like AWS. We spin up a RabbitMQ service, or we eventually use the Azure service bus. Is there any way, in terms of the Akka model, or you can also spin up something on the cloud to avoid any build-up of memory with the Akka model, or it works in such a way that as soon as it's done with its operation, it just shuts down? And then, of course, for instance, let's say you want to process, let's say 300 records in a CSV or in an Excel file. Might probably want to, let's say, so how we'll handle it is, let's say, push it to Azure Blob Storage, send a message to the consumer or the actor to download the CSV and then process it, something like that. Does it have a default timeout, or you can increase the timeout for the actor to process whatever you want to process, so that you don't have any request timeout or anything of that sort? That's my final question. Thank you very much. I know that the questions are scattered, but just bear with me, and then let me see if you get where I'm coming from.
Yeah, I get where you're coming from. So what you're talking is very broad, although I try to keep it very basic. So there are other things too you can do. For instance, in your case, we have you can create the actors. You can have a cluster too, whereby you create your actors. You can have .NET, the Akka.NET comes with different packages to handle some of these things. You can also have create a stream-like functionality with Akka as well. So I think what you are talking about is very broad, but then you can have that done as well. So we have you can create access to communicate on 2 different networks, which is way advanced than this. You can also create that's using the Akka.cluster. You can do all this complex logics too as well.
Okay, understood. Yes.
Okay.
We've already spoken about the clusters, so that's fine. All right.
Yeah. So thank you, sir. We can see Foster is also back again. Foster, can you go ahead with your question?
Okay, this one is a very minor, let me say, later one, David. So based on the explanation, I could perceive that in the context of API development, Akka can facilitate the response time in a sense that, let's say I have multiple logics to perform. but maybe after performing the M1, which is the core, I can send response whilst I handle or designate the rest to maybe Akka. Would that be the case?
Yes. So basically, that's what it's supposed to do. So you see, you shouldn't just keep your users waiting. If they are waiting for a response, just give it to them, depending on your logic. They are waiting for a response or whatever that has to be done, you just give it to them. And anything that can be handled separately, you just let the actor do it. So this it contributes to reducing the your response time, which is also going to affect positively how your API works or your API's functionality. So basically, that's basically what it's supposed to do, or what's the advantages it brings to you.
All right.
Okay.
Thank you.
Okay. So I can see that there is no question.
Okay.
Okay. Yeah. So David, thank you so much for your presentation. This is very wonderful. I think we have learned a lot, and I myself have learned a lot, and then we are going to practice this. And one thing is that we are going to make this code available to everyone. So in case you want to practice, and then we will send you an email, or there will be a link for GitHub repo. We already have a GitHub organization, so we are going to put these resources in there for everyone, so that you guys can then go there and then have a look. So thank you everyone for joining. This has been a wonderful event. And next month, we are also going to continue with this Akka stuff. I can see there is a lot of interest in here. So next month, we are going to continue with that. And then we see maybe how we can implement some kind of advanced stuff. And yeah, so there's going to be a wonderful event coming up next month. So thank you everybody for joining. This is a record season, so we are going to make it available on YouTube for everybody who wants to go there and then rewatch. If you have any question you can always reach out to us, and then we will help you. So thank you guys for making this event wonderful, and thank you guys for supporting the community. Together we build a strong community. So thank you everyone. I'll see you in next month, October. So we are going to end it here. So thank you all, and then we will see you next month. Yeah. So if everybody also, if you have something to say.